So today I will talk about triple product in vector algebra. There are two types of triple product about which we will talk about. One is the scalar triple product, and another is vector triple product. So it's like A dot B cross C, and it's like A cross B cross C. So it's basically a scalar quantity and it's a vector quantity. So here in this lecture I will talk about the scalar triple product. So let us first of all define scalar triple product. So for the given three vectors, vectors A, comma B and C, the dot product of one vector with the cross product of other two vectors is called scalar triple product. For example, A dot B cross C, it's basically the vector triple product. Sorry, it's the scalar triple product. And in place of this we can also call it as like this, and both are identical. We will prove it later on. So let us now express scalar triple product in terms of its components. So for this let us choose a vector is axi cap plus ayj cap azk cap, b vector is equal to bxi cap vyj cap and bzk cap, and say c vector is cxi cap cyj cap and czk cap. So we are interested to find out A dot B cross C. So let us first of all try to find out that what is B cross C. So what is B cross C? So this B cross C, it can be written as I cap, j cap, k cap. It is bx, by, bz, cx, cy and cz. And this simplifies to I cap by, bz, cy, cz minus j bx, bz, cx, cz plus k cap, that's vx, by, cx, cy. Now we are interested to find out a dot with it, so that means now A dot B cross C this can be written like this. It is axi cap plus ayj cap azk cap. It is I cap by bz cy cz minus j bx bz cx cz plus k cap bx by cx cy, right? So now what will happen if I take dot product? Then this will sit with it, because as we know that this a dot b is equal to ax bx, means x components, and then y components are put together, ay by and az bz. So that means it is the x component, it is the x component. So x component will sit with the x component, y with y, and z with z. So if I do this, then what we are getting? We are getting ax by bz cy cz minus ay bx bz cx cz plus az, it is bx by cx cy. That's what we are getting. Now it can be written in the form of a determinant. So it's ax ay az, it is bx by bz cx cy and cz. So thus we conclude that from here that this a dot b cross c, it can be written as ax ay az bx by bz cx cy and cz. So this is it, right? Now there is a very important point which we have to keep in mind, that if we interchange dot and cross, if we interchange dot and cross, then scalar product remains the same. Then scalar product remains the same. So that means if I put it here and this will be here, means it's the exchange. That means then the dot product will remain the same. Means a dot b cross c, it is equal to a cross b dot c, right? So what do we do? Let us start with it, this part. Let us try to prove it. So if I consider this a cross b dot c, so it can be written like this: I cap j cap k cap, it is ax ay az bx by bz. So it is the value of this part and multiplied by with it, that cxi cap cyj cap and cz k cap. So as I did in the earlier case, so what will happen? This ijk, they are simply replaced by cx, cy and cz. So I can directly write down it like this: cx, cy, cz, ax, ay, az, bx, by, bz. Means generalizing the previous idea. So it is like this. So now what I will do, if I exchange, means if I exchange this means I will apply the operation R2 and R1. Then what we are getting, the result which we are getting, then if we exchange either two rows or columns, then sign will be negative. This is the property of a determinant. So that means it is AX, AY, AZ. It is CX, CY, CZ, BX, BY and BZ. And let me exchange now these two. This will goes to here and it will goes to here, and then again negative sign will also be there. Means it is minus of minus. It is AX, AY, AZ, CX, sorry, not CX, but it is BX, BY, BZ, CX, CY and CZ. If I do this, then minus minus will become positive, right? So what does it mean? It means that this will be positive. So that means this is equal to, if I sum up this result, then I can say that this A cross B dot C is equal to AX, AY, AZ, BX, BY, BZ, CX, CY and CZ, and which is further equal to, because it is basically A dot B cross C as I proved here, right? So that means if we exchange dot in the cross, then the scalar product will remains the same. So hence we have proved the given result. Now let us talk about the physical interpretation of scalar triple product. Next is the physical interpretation of scalar triple product. So that means first thing it tells us about that, it gives us the volume of parallelepiped, and if scalar triple product, it will be 0. That means vectors are coplanar. Vectors are coplanar. Right. So let us first of all talk about the volume of a parallelepiped. So consider a diagram . So this is a parallelepiped which we have considered. Now let us say that it's a B vector and let us call it as a C vector. Then B cross C will represent the area of this region, right? So this is basically B cross C. It is the area. Now if I draw a perpendicular from here over it, and let us call it as H. So that means area of base that is, let me rename it. So this is a point O, it is P Q R O, P Q R O, S T U V, and let us call it as this point as W. And let us do one thing. This is represented by B cross C, and B cross C basically it is the normal, so it is the normal direction, and let us say that this point is N, just for the sake of simplicity. Now area of the base is basically B cross C. So let me talk about now the volume of parallelepiped. Volume of parallelepiped is equal to area of parallelogram formed of OPQR multiplied by height, and the height is h here. Height is represented by h. So what is this height h? This h is basically perpendicular from U over plane OPQR, that is UW is basically h, right? So that means it is B cross C gives us the area of this, and this is the height, and let us call it as h, or I can say that now since this N is perpendicular over this is perpendicular, so also U is also perpendicular, so that means this PN is parallel to UW from this diagram. Also let us say that this is making an angle theta, this UP making an angle theta with this, and say this vector is A vector, this vector is rather than let us call it as A vector, so that means PU vector is A vector. So now this angle is theta, then this angle is also theta. So in triangle PUW, in triangle PUW, I can say that angle PUW is equal to NPU. So if this is the angle, so that means then in this particular triangle I can say that UC over PU is equal to cos of theta. What is UC? UC is equal to H upon mod of A, and it is cos of theta. So therefore H comes out to be mod of A cos of theta. So let me put its value here. So if I put its value here, then I can say that this is equal to, means volume of parallelepiped, basically it is B cross C into mod of A cos of theta, right? So this cos of this theta is the angle between vector A and n cap. So that means this can be written in the form of a dot product. So that means I can say that this A dot B cross C, right? So thus I can say that volume of a parallelepiped is basically the dot product. Another thing which we have to keep in mind, that the vectors are coplanar. vectors are coplanar, second thing which we have about which I am talking about, means if A dot B cross C is equal to 0, which implies vectors are coplanar. So that means B cross C represents what? It represents area. But if it is 0, what does it mean? It means A B cross C, their mod and cos of theta, it will be equal to 0. So this is possible if and only if cos of theta will be 0. Cos theta will be 0 means cos of 90 degree will be 0. And say its unit vector is n cap and A vector is like this. So angle between A vector and n cap will be 90 degree. It means if n cap is acting along like this and A and B vectors are like this, this is B vector and this is C vector, so that means A vector must be perpendicular to n cap, and so this is possible. So this is possible if A vector is along the plane or it's A vector is lying in the plane containing B and C, and hence we can say that A, B and C all are in same plane. That is coplanar. So that means if A dot B cross C it vanishes, that means A, B and C are coplanar, right? So that's all for this today's lecture.